Well, here we go. Starting into Chapter 9, we are moving on with what we had before, which was our polynomials. We are continuing with our polynomials, only now we're going to graph them. And now I know you're making faces kind of like this, right? A sad face. Oh, I'm so sad. No, don't be sad. This is easy stuff, and I'm going to take you through it really slowly. We have a lot of time. You have to practice it, though. First thing, quadratics and their graphs. So we're just talking basic stuff. Well, we've already graphed these before. Do you remember what these are called? They are parabolas. Yay! Or as some of you so lovingly called it, a parabola. But yet no. A parabola. So they have shapes like this. Now, we're going to eventually go much more in depth. We'll use factoring eventually, but in this section right here, we're just kind of graze over the main concepts, main ideas. And the further we go, we'll learn how to graph these shapes more accurately, as opposed to before, where we just put it on a graph. Okay, so first is, why is it called a quadratic when quad means 4, right? You're making this face, and you're like, what in the world is going on? I don't understand. Huh? Well, it comes from the Latin word quadratus, which means square. Okay, so we're not basing it on the word quad as much as we're basing it on quadratus, which is Latin. So since this term right here, x to the second power, is read as x squared, it is a quadratic. Now this thing right here, I don't know if you can see it or not, but it's 3 dots in a triangle formation like that. That means therefore, which maybe would be a good idea to write down, because you probably will see it in the future, if not in my class, other classes. So it's just kind of a, a little tool to keep in your back pocket. Yeah, I said. Okay, so now for vocab, which is your favorite. Yay! Quadratic function. Function where the highest exponent is 2. So remember in the polynomials we were doing when we were factoring, and we would have something like 3x squared plus 2x minus 4. We would have equations like that, and then we would factor them. Well, this is called a quadratic because the highest exponent right here, you'll notice this x squared is the highest. Now remember, in some of them we took out the middle value and it looked like 81x squared minus 100. Well, this would still be a quadratic because it has the x squared term as its highest exponent. However, if we get into x cubed or like this right here, that is not a quadratic, okay? That's actually called a cubic function, which we get into later. Okay, so we have standard form, which we dealt with before, putting the highest exponent first and then working our way down. Now, standard form does not pay attention to the order of the coefficients. We're not putting highest coefficient to lowest or anything like that. We're putting highest exponent to lowest exponent. Now, when you see A, B, and C, A is just representing the first coefficient, so A for this one would be 3, B would be a positive 2, and then C would be a negative 3. Where in our second equation, or our second expression underneath that, this 81 would be our A, and this negative 100 is our C. So what happened to the B? Well, since there isn't one, that would mean technically B is 0. Okay? And just to give you one more example of what you will see, let's say you have 4x squared minus 6x. Well, then in this case, we have our A and we have our B, which is negative 6, but we don't have a C, so our C is 0. Okay, so those are kind of important to hold on to because we need them later on, so it's just kind of the intro now. Okay, so now we have the quadratic parent function. So remember back when we were just graphing lines, it was just a line. Well, we have these functions now that are quadratics, which mean they have that U shape. All right, looks something like this. And this is basic where we're starting from. Now remember, this one is the one that opens upward, And this one, because there's a negative in front of that x squared, this one opens downward, so this would actually be a parabola going this way. Okay, so this is the parent function. What that means is we will eventually manipulate this to become something else. Okay, so like I was saying earlier, let's look more closely at parent function. So your face is looking like this. You're like, parents, parents, my parents, no way. Ah, no, right? Well, no, not those kind of parents. So think about when we had y equals x, and we just graphed a line, and it looks something like that, right? Or we had y equals negative x, graphed a line, something like this. Well, then we could have something like, oh, well, let's say it's y equals 3x. Well, now the slope has changed, or so we changed the slope. Or y equals 2x plus 6, then we change the y-intercept. So we're changing it, we're starting with this basic graph still going upward, okay, so we still have the line going upward, but we are changing it to fit our slope and our y-intercept. And then same goes for over here. So we're changing it to fit. So these would have been our parent functions for linear equations. And remember, linear is because it graphs a line when you make that. So those would be our parent functions there. Okay, now continuing the vocab. I know I gave you a little break, but we're not totally done. With this parabola, and with every parabola, you will have a spot called the vertex. And the vertex is where it either comes down and then starts to curve back up again, or if it was a parabola opening downward, then the vertex would be the point where it comes up and then starts to come back down again. So it's kind of like the bending point. If you were to flatten it, where would it bend? Kind of something like that. Now, we also have something that is called the axis of symmetry. And that is, you all know what the word symmetrical means, right? So symmetrical is to cut exactly in half. Symmetry, cut in half. Okay, so axis of symmetry is wherever in this parabola that we would cut it so it's equal on both sides. All right? So what you will always notice is that the vertex and the axis of symmetry are always in that same spot. So if I pulled this over here, and let's say I shifted it right here, well, the axis of symmetry would be here, which would mean our vertex would also be in that general area, which would be right there. See, it's not so bad. Eventually we'll learn how to find those, but for now, just know what it is. And then we have two more things with minimum and maximum. Minimum. Now, this one gets kind of tricky because this it would actually be a positive x squared graph. But the vertex is actually a minimum because it's opening upward, which means the part where it goes down starts to come back up is the lowest point on the graph. Now with the maximum, this is a negative x squared graph. Okay, so that's negative x squared, which means that vertex right here is actually technically a maximum point because it opens downward. This is the highest point on the graph. Now the reason I say this is tricky is because you see negative x squared and think, oh, negative means small, so it's minimum. But that's not right. Think of it in terms of the actual shape of the graph. Okay, same with x squared. If you see x squared like that, even though it's positive, the vertex is actually a minimum because it opens upward as opposed to downward. Okay, so is the parabola a minimum or a maximum, and why? Why? Well, all we're looking at, this is it, x squared term and its coefficient right here, right here, right here. So you're only paying attention to your x squared, or in this case v squared and n squared. Those are the only terms you are looking at. So positive x squared means minimum. Negative x squared means maximum. Okay, so those are the only terms you're looking at. So with this one, we have a positive 1x squared, so that would be what? A minimum, exactly. Same here, a positive 1x squared, minimum. Now here we have a negative 1v squared, which is a maximum. And then we have a positive 2x squared, which would be a minimum. And then we have a negative 1n squared over 6. Well, it's a negative, so it is a maximum. See, that's not so bad, right? You can identify those pretty easily, I think. And guess what? That's it. So now it's time for these guys to have a dance-off, and let's see who wins, shall we? I think this guy right here is the winner. Winner, winner, chicken dinner. Have a good night.